Hello friends, hearty welcome to you. In this session, let's start series of videos on quadratic equations for 10th grade. So, in this particular session, we will understand about what is a quadratic equation and how to check whether a given algebraic expression or a equation is a quadratic equation or not, and also how to represent a real life scenario in terms of a quadratic equations. First, let's try to understand what is a quadratic equation. We know that last year we have learned about quadratic polynomials, and we represent quadratic polynomials by p of x, a variable in x, is given by ax square plus bx plus c. This is a quadratic polynomial. Now you take this polynomial and equate it to 0 by saying ax square plus bx plus c equal to 0, then this equation is called as quadratic equation in standard form. So the standard form of quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0. Because if a becomes 0, then it will become a linear equation in one variable. So that's simply about the quadratic equation. Now let's look at a real life scenario and see how we can represent it in the form of a quadratic equation. Let's look at this scenario. A train travels a distance of 560 kilometers at a uniform speed. If the speed had been 10 kilometers per hour less, then it would have been taken 1 hour more to cover the same distance. We need to find out the speed of the train. So a train travels a distance. The distance is fixed, 560 kilometers at a uniform speed. If the speed had been 10 kilometers per hour less, it would have taken 1 hour more to cover the same distance. We have to find out the speed of the train. In this session, we will not find the speed of the train, but we will try to represent this scenario in the form of a quadratic equation. So let's try to understand this. We have been given distance, and we know distance is equal to speed into time. We have to look at the condition given to us. If the speed had been 10 kilometers per hour less, it would have taken 1 hour more. So we have to compare the times now, and we have to say t1 minus t2 is equal to 1 hour. Because we have been given that the difference between both the scenarios, the time is equal to 1 hour. And we know the distance is nothing but 560 kilometers. Okay, now let us say the speed of the uniform speed be x. Let us say the speed be x. Now what will be the time taken? The time taken will be nothing but equal to 560 by x. If the speed has been 10 kilometer less, it will take more time. So it should be t2 minus t1. I will write it as, where first scenario is the scenario where it is going at a uniform speed, that is equal to 560 distance divided by speed, that's equal to x. Now what will be the other scenario? The other scenario, the distance is the same, but the speed is reduced by 10. That means it's nothing but now x minus 10. So the time it took when the speed was less than 10 kilometers, and the time it took at the uniform speed, the difference between them is 1 hour. Now we have to convert this into a quadratic equation. How to convert that? For that we'll just do simplification. So let me write it as 1 by x minus 10 minus 1 by x, and multiply that with 560 is equal to 1. Or can I say 1 by x minus 10 minus 1 by x equal to 1 by 560. Let's go to the next step. So if you take LCM, you will have x into x minus 10, and we'll have x minus of x minus 10 is equal to 1 by 560, which is nothing but equal to 10, because x minus x plus 10, this is x minus x plus 10, x will cancel. 10 by x into x minus 10 is x square minus 10x equal to 1 by 560. If you simplify that by doing cross multiplication, you will have x square minus 10x minus 5600 equal to 0. You do cross multiplication, you will get x square minus 10x equal to 5600, x square minus 10x equal to 5600. So if you subtract, you will get x square minus 10x minus 5600 equal to 0. So now if you look into this equation, it is of the form of ax square plus bx plus c, ax square plus bx plus c equal to 0, with a equal to 1, b equal to minus 10, and c equal to minus 5600. In the coming session we will see how to solve them. We can use splitting the middle terms, or we can use quadratic formula. We will look into that in the coming sessions. Now we have represented a given scenario in terms of a quadratic equation. Now to solve or find out the speed of the train, I have to solve this quadratic equation. Now what will be my steps to solve this problem? Let's write down the steps before till we go to the calculation part. We'll first write down, let the speed of the train is equal to x kilometer per hour. The time taken is equal to distance by speed, that's equal to 560 divided by x hours. That's the first step. Then we will say that the time, the speed, if the speed had been 10 kilometer per hour less, right? The speed in the second scenario, the speed in the second scenario, or the scenario where the speed is less, is 10 kilometers less, so it will become x minus 10 kilometer per hour. Now the time taken, can I say that this is also equal to t1? The time taken, this is t2. Time taken to cover the distance, we can say that to cover the distance equal to, again distance by speed, that means 560 divided by x minus 10. This is hours. Now after that we will write our statement whatever we have written earlier. We will write down now. Next, given the time difference is t1 minus t2 minus t1 is equal to 1 hour. We know that if the speed is less, if the speed is less, the time will be taken more. So then we'll write down the second scenario when the speed is less by 10 kilometers minus the original scenario when the speed is uniform speed of x, the difference is 1 hour. After this you can start solving and form the quadratic equation. Okay. Now we understood, given a mathematical scenario, how to convert that into a quadratic equation. Now suppose we have been given an equation. Now how to say whether it is a quadratic equation or not? For that very simple. We will take the equation, we will try to simplify that, and we will see whether it will boil down to ax square plus bx plus c equal to 0 format or not. If it is comes down to the standard form, then we will say it's a quadratic equation. Otherwise we will say it is not a quadratic equation. Let's look at one example like that before we wrap up this session. Now look at this. We have been given x plus 2 whole cube equal to 2x into x square minus 1. We have to simplify this and we have to check whether the following is a quadratic equation or not. So algebraic identity, a plus b whole cube. What is the formula for that? A plus b whole cube equal to a cube plus b cube plus 3ab into a plus b, or can I say 3a square b plus 3ab square. Now my first step will be expanding this. A is x and b equal to 2, so I'll write down x cube plus 2 cube is 8 plus 3ab, that is 3 into 2x into a plus b, that is x plus 2, equal to 2x into x square minus 1. The next step will be, we'll try to simplify this. We'll write down x cube plus 3 into 2x is 6x, 6x into x plus 2 plus 8 equal to 2x into x square is 2x cube minus 2x. Now we'll simplify further. It will become x cube plus 6x square plus 12x plus 8 is equal to 2x cube minus 2x. Let's shift everything to right hand side because we have 2x cube here. It will become 2x cube minus 2x minus x cube minus 6x square minus 12x minus 8 is equal to 0. Nothing but 2x cube x cube are like terms, so I can say x cube minus 6x square. Again 2x and 12x are like terms, so I can simplify that, minus 14x minus 8 equal to 0. Is it in the form of ax square plus bx plus c? Is it in the form of ax square plus bx plus c equal to 0? No, it's not in the form. So we will say that this representation, whatever we have been given, this equation is not a quadratic equation. So what we have to do is very simple. We have to just use algebraic identities, simplify them, and use the basic rules of algebra, linear equations in one variable. Let's look into the next one. So let's look at this one. 2x minus 1 into x minus 3 equal to x plus 5 into x minus 1. We know how to do this. 2x into x, 2x square, 2x into minus 3, minus 6x, minus 1 into x, minus x, minus 1 into minus 3, plus 3 equal to x into x, x square, x into minus 1, minus x, plus 5 into x, plus 5x, 5 into minus 1, minus 5. Let me check that. 2x square minus 6x minus x plus 3, x square minus x plus 5x minus 5. Let's simplify this. We have 2x square like terms, minus 7x plus 3 equal to x square. We have like terms, plus 5 minus 1 is plus 4, 4x minus 5. Let's bring everything to left hand side. We'll have 2x square minus 7x plus 3 minus x square minus 4x plus 5 equal to 0. This is nothing but equal to x square minus 7x minus 4x is minus 11x plus 3 plus 5. We have like terms here, we added them. Then plus 3 plus 5 is plus 8. And 2x square like terms, so we have just subtracted them. So we have x square minus 11x plus 8 equal to 0. Now let's compare this with our standard form. Standard form is ax square plus bx plus c equal to 0. A equal to 1, b equal to minus 11, c equal to 8. So we have everything following the standard form. So this is a quadratic equation. In the next session, we'll try to solve some problems where the scenarios we'll try to represent them in the form of a quadratic equation. Then after that we'll solve them using factorization, or to be specific, splitting the middle term, which we learned in the earlier classes. So I'll catch you in the next session where we'll solve some more problems related to quadratic equations. Thanks for your time and support. Bye for now.